The global optical networking market is anticipated to progress at a CAGR of more than 8% to reach a valuation of $25 billion by 2029. How do you see this market evolving in India?
The global optical market is definitely growing, and India is one of the big growth regions. Just to give you a context, India deployed about 17 million fiber kilometers a year. And again, optical fiber is the backbone of the optical networking, and that's basically what our entire internet and connectivity is carried upon globally today. India deployed about 17 million fiber kilometers in 2021. This year, in 2022, it's expected to almost double to about 33 million fiber kilometers. And the main reason why we're doing that is because of the advent of all these modern networks, everything from cellular networks onto every other kind. Here's an example. When you talk about cellular towers, we actually have fiber going to the base of those towers to take up the signal from there. And today, there's probably about 33% of our cellular towers in India are fiberized, and we need that to get to about 80% in order for that network to be really resilient. So given that India has a huge growth potential for optical fiber, not just this year, but into the near future. And what this has meant is that Indian manufacturers over the years have invested quite a bit of capital into into production of optical fiber, of cables, of interconnects, and the passive connectivity layer, well over about 5,000 crores, give or take. And again, providing jobs for, I would say, both direct and indirect labor for about the order of 4 million. So this is a huge industry for growth, and it very much fits into the government system of Make in India, Atmanirbhar, and all that. So India's capacity, if you look at it for producing fiber, is about 100 million FKM, and we consume only a fraction of that. It's a huge export-oriented industry. So this is basically what's happening in India. The domestic consumption is increasing, the fiber networks are growing, local consumption, local players are strong and exporting, and so this is very much a growth industry in India.
Digital economy can only be realized by building a robust optical fiber network. What kind of technologies should be leveraged by telecom operators to achieve this?
Well, there are two aspects of this, and I'll actually get into a little bit of both. See, the first one is that what should telecom operators be thinking about to build a robust optical fiber network, right? And so this actually boils down to both the deployment of the network, as well as the technologies that are used to increase the data rate and so on and so forth for that. When deploying a network, there's a lot of different things that you can do in terms of both the choice of fiber, which I just talked about, maximizing your capacity of the network in terms of cables, which I also briefly referred to, as well as a number of different deployment techniques to minimize your time taken for deployment of networks. So these are things that we have a lot of R&D in India working on. And then there's this whole aspect of other areas that you need to think of. Like, for example, networks themselves are changing. And you need to be able to anticipate where networks are going, use the aspect of where industries are moving in terms of if you look at the advent of networks, it went from long distance networks where cities were connected down to intra-city, making the rings around which the data can be transmitted, and then all the way down to edge networks, which is actually fiber terminating in your house, right? And so there's a lot of different technologies which are required for this transition to happen from city to city networks all the way to fiber networks in the house. So I think that telecom operators are both well aware of this, but the rapid pace of change, I think, also has something to do with the adoption. I would say that in India, we have a chance to leapfrog technologies, which, for example, in other parts of the world, they have actually taken sequential steps. We can actually avoid the intermediate step and go straight, for example, into the most advanced fiber types today, which were not available about 10 years ago when there were networks being put down in the West. So I think we have an advantage over here if we choose to use it in basically leapfrogging from what technologies looked like when the last wave of deployment happened in India, which is probably about 10 years ago, to now going forward. Because remember, you're going to be building a network for the next 20, 25 years. So if you're thinking about technologies that you need to use today, it needs to be something which can carry through for all that time and not something which has worked until now, if that makes sense.
fiber rollout projects, especially in India, have been slow-paced. The fallouts are evident in the time and cost overruns that plague large-scale projects. What kind of products are needed to address these challenges?
So, yes, fiber rollout projects typically do run slow, and one of the things that helps. I mean, there are many different ways of which you can look at this, but one of the things that we really need to consider um, is that we need to think about the people who are actually putting down the networks on the field, right? So the first thing is that avoid putting fiber in as much as possible repeatedly. So build in as much capacity up front as you can, right? That's the first thing. So use high density cables. Now, high density cables take up a lot of space. So there's a lot of miniaturization technologies that are coming to making sure that you actually have these cables fitting into small footprints. Now, then there is a speed issue, right? Now, if you have a fiber, or if you have a cable with a fiber count of, say, 200 to 300 fibers in a particular cable, each fiber splice takes you about 2 minutes. So when you think about an operator, a field technician sitting over there and trying to splice this on the field, 300 fibers taking 2 minutes each, that's going to take him, what, 600 hours, which boils down to he's going to be there for a week in a particular location trying to splice these fibers. But we have these things called ribbon technologies where you take 12 fibers and you bond them together. So you're splicing 12 to 12 instead of 1 to 1. So suddenly that goes down from 600 hours to 50 hours, which basically takes 2 days. That's one way you can increase the speed of rollout. The second one is that one of the things that we worked on is this fiber called Stellar, which basically is a bend-insensitive fiber, which basically helps the installer splice it right for the very first time. Because I just talked about the speed of splicing. When you're actually splicing things and you don't get them right, you have to redo the splice, which takes additional time. So making sure that gets avoided is a big thing. And the third thing I've mentioned is this field connectorization should be taken away and put into the factory. So pre-connectorized solutions where we give plug-and-play boxes. You put it in the field and you actually have to make certain plug-and-play connections as opposed to actually doing the labor-intensive things in a harsh environment in the field. These are examples of things that will really help to move the fiber rollout pace to be much faster and to increase the quality of fiber rollouts, because you're taking all of that complexity out of the field and putting it back into the factory or through robust solutions which can help you do that. And these are all solutions that, by the way, have a lot of indigenous solutions, because we, for example, have innovated all of these solutions in our labs in India. We have like 3 or 4 labs in India where we developed all these technologies. So this is very much a place where we in India are at the cutting edge of where what technologies are needed, and these are actually seeing application across the globe, and hopefully in India too very soon.
How do you foresee the market for optical networking evolving in the near future?
Well, actually, this is an incredibly exciting time to be in the optical networking space, because what you're seeing is you're seeing this massive expansion in data and the way data is being consumed across the globe because of emerging applications. So we frequently hear about these things like connected factories, artificial intelligence, driverless cars. You keep hearing about all of these things in the media, and but the one common thing to all of these is that they require a lot of data with what is known as very short latency. Latency is the amount of time it takes for a signal to go to one end and come back, right? So when you're talking about latencies of 1 millisecond, which is needed for applications even today, leave alone the applications of tomorrow, compared to what was 50 milliseconds or more with the standard 4G connection or cellular connection, you can see how much of that has to change the network. So you're having networks moving closer to what's called the edge or the point of consumption, right? So you will have like cellular tower equivalents in your house so that your cellular phone will be handing off inside your house to a fiber network. There's a massive change in the way networks are being laid out, which means there's a massive change in fiber, in cables, and also what is called optical wireless convergence. Basically, these two networks, the wireless network and the optical networks, are all becoming one and the same network with two different parts which are complementary to each other. So this is actually another area of this is going to be critical. Now, where this will all take us is that, now this might sound very complex to somebody who's not in the field, but you'll see the impact of that. Anytime that you require data, usually you end up having a lot more data capacity put in than is needed because of the way the capital infrastructure cycles work. And then applications expand to fill that data. Like, for example, we watch video on our phones without giving it a second thought, but you could not do that 5 years ago, right? And we could not be having this conversation 5 years ago. So when you're thinking about that, optical networks are going to be increasing dramatically across the world. So right now, if you look at the numbers, for example, the total market for optical networks, when I'm talking about optical fiber and cable, is about $14 billion, right? And so this is probably going to, like by the end of this decade that we are in right now, in the next 5 or 6 years, that's going to probably grow almost to double, about like 8 to 9% growth per year. And that's a conservative figure. We are in actually an upswing of the capital cycle. And that is actually needed for 5G. It's needed for all kinds of future expansion. So I would say the coming decade is going to be something which is actually pretty critical as companies, governments, etc., think about fiber as a critical resource that is needed for the growth of the economies. And in India's case, to make India self-sufficient in the technologies that it needs to take it down the path of growth from an infrastructure, from a connectivity standpoint, not to mention a lot of other areas like defense and so on. The IT and the telecom industry is definitely going to be a critical aspect in India's growth in the next year, and so it will be worldwide.